Okay, so we're doing some inequalities here. If you take a look, let's start with number one right here. I have -5 is greater than p over 3. So I want to solve for p, so I'm going to multiply both sides by 3. When I do this, I get -15 is greater than p. The only question now is which way to shade. And what kind of dot to do. So I'm going to make my number line like this. And you can include as many or as little numbers as you want. It's first off, it's going to be an open circle at -15. Remember, if there's not a greater than sign, if there's a greater than, if there's an equal to sign, that's when I want to shade it in. This means I'm looking for all the numbers that are strictly where -15 is greater than p. So I'm wondering what numbers make p work here. So if you see that you want p as all the numbers smaller than -15, it's this direction. Some people, they prefer to like plug in numbers here to like see if it works. Like if p was 0, would this be true? No, because -15 is not bigger than 0. Even though it looks like -15 is like, well, 15 is bigger than 0. But remember, -15, like I'd rather have $0 than -15, right? So it's kind of your call on how to figure it out. Another way that I've seen people kind of do this is they always have the variable on the left side. So if you switch this and you say p, see how this like little point is like touching it like that, -15. You have to be careful when you flip it because see how I flipped the sign there too. But if you always have the variable on the left side, this middle sign, see how it's like it looks like an arrow that's pointing to the left. Some people remember it like that. As you can see that there's the less than sign. So however it works for you, that's how you solve that one. 2 is a very similar problem, but I want to go to number 3, which kind of gets into some of the issues that can happen. So I have 11 is less than or equal to 4 plus x divided by -2. It starts off easy enough. I subtract 4 from each side and I get this. Now here's the issue, where the issue comes in. I'm going to multiply both sides by -2. And anytime that you multiply or divide by a negative, you have to flip the sign, right? So when I multiply this by -2, that becomes a greater than or equal to sign. So this becomes -14 is actually greater than x. So on my number line, it should look like this. I got -14, -13, -15. So it's a closed circle on -14. And I'm looking for all the numbers where it's smaller than -14. So x is smaller, so this is the direction of smaller, right? It's everything to the left of. Same things apply if you want to actually flip that like this. You can see how this makes an arrow to the left if the x is on the left side. So I'll leave that up for just a little bit longer. That sign actually makes an arrow to the left, which is another way of remembering that goes to the left. The reason why you have to flip on a negative is no one here would argue. Let me just do some erasing here real quick. There we go. No one would argue that 8 is less than 10, right? No one would argue that. And if I like subtracted 2 from each side, that's no big deal. Yeah, 6 is still less than 8. And if I, added 1 to each side, everything plays by the rules, right? That's still true. But what happens if I take this original one and I multiply by 2? Still, everything's good. 16 is less than 20. But the problem comes in if I multiply this by -2. Watch what happens. I get -16 is less than -20. And that kind of looks true. Like you can deceive yourself in saying like, oh yeah, that's true. But like, would you rather be $16 in debt or $20 in debt? now this sign has to flip to keep that as being true. It gets more ridiculous if you look at it like this. You know, maybe this would be a better way to say, if this is -8, right? -8 is less than 10, right? If I multiply both sides by -2, I get +16 is less than -20. That doesn't make a lick of sense, right? So you have to flip that sign, right? Same thing happens with division, because now we're talking about the size of the number, you know. Okay, so I'm gonna do just one more from this front page, because they're just kind of solving problems after that and keeping track of signs. So let's just skip to the big one. Let's do 8. So that's 4p plus 2 times 3p minus 1 less than or equal to 7p plus 19. So the solutions to the other one should be included with your work. So anyway, you can check your results there. But let's do 8 together. 8, I'm going to do a little distribution. So I get 4p plus 6p minus 2 is less than or equal to 7p plus 19. I got some like terms. I can subtract 7p from both sides. I'm getting close. Okay, so I've got all my p's in one spot. It's kind of nice. I'm going to add 2 to both sides. So I get 3p is less than or equal to 21. Let's say, just for a second, just for argument's sake, that was a -21. If I was to divide both sides by 3, I would not flip the sign, right? I would have to be dividing by a -3, not dividing 3 by a negative number, right? So if it was -21 and I divided by 3, I don't flip the sign. But if this was a -3 and I divided both sides by -3, that's when you flip the sign. But as it is, I have no negatives. My life's good. I'm going to divide both sides by 3. And I get p is less than or equal to 7. So how do I graph this thing? Erase. Give myself a little room. Get out of there. 6, 7, 8. So you can either do the trick where that looks like a left arrow, or, so I know I'm going to be shading to the left, or you can think about p is all the numbers that are smaller than 7. So this sign is choosing 7 over our measly p, so we're all the values this direction. Filled in circle because it's less than or equal to. So let's flip over and do some graphing. Let me actually just do it like this. So the problem is y is less than or equal to 5/4 x minus 5. So to solve this thing, first I'm just going to completely ignore the fact that there's a less than or equal to sign. I'm just going to graph it normal. I have a y-intercept at -5, and I have a slope of 5/4. 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So I've got my line. Now remember, if the signs are less than or just greater than, that's when I would connect this with a dotted line like this, because the line itself doesn't provide a solution. In this case, it's less than or equal to, so the line itself makes it true, so that's going to be a hard shaded in line. So if it's less than or greater than, it's going to be a dotted line. If it's less than or equal to or greater than or equal to, it's going to be a solid line that you're going to connect to. The next thing I need to check is which way to shade. My answer is either going to be I'm going to be shading everything on this side, or I'm going to be shading everything on this side. At this point, if you have no clue, just flip a coin and just guess, right? But if you want to actually know how to do it, the easiest point in the world to plug in is 0, 0. Watch what happens when I plug in 0, 0. I got 0 is less than or equal to 5/4 times 0 minus 5. 5/4 times 0 is 0. That's why I chose 0. 0 is just a convenient point to choose. So I got 0 is less than or equal to -5. You just have to determine if that's a true or false statement. Is 0 less than or equal to -5? No, it's not. So this point doesn't work. So what that means is every point on this side does work. So all we have to do is check one point. Now at this point, if you're an overachiever, you could check out a point like 10-0 or 9-3 and confirm that it does work. But just knowing that one point doesn't work on the other side lets us know that everything on the other side of the fence does work. The next problem we have is one in standard form. Whoa, lots of erasing I got to do. It's x plus 2y is greater than -6. So what I want to do in this problem is I want to, first I need to graph it. Now there's two different ways to graph it, and I'll show you both ways. The first one is I can find the x and y intercept and just connect the points. So remember the strategy for that is if I plug in a 0 for x and solve, I get 2y is basically, okay, so divide both sides by 2 and I get y equals -3. So that's going to get me my y-intercept, plugging in a 0 for x. Now I'm going to reverse it and I'm going to plug in a 0 for y. And I get x plus 2 times, get out of here, 0 is greater than or equal to -6. Really, I'm just pretending it's equal to right now. So I basically got x is like equal to -6. Because I'm just, and that gives me my x-intercept. So I have my 2 points. So that's one way to do it. And it's not or equal to. So it's going to be a dotted line like this. Your other option is to solve this thing for y, to get it in a slope-intercept form. So subtract x from both sides. So I get 2y is greater than -x minus 6. So I'm going to divide everything by 2. So I get y is greater than, that's like -1x, right? So that's like -1/2 x minus 3. So you can see if I would have converted it to slope-intercept form, yeah, I have a y-intercept at -3. And look at my slope. It's down 1 over 2, down 1 over 2. And in this direction, you can see it's going like that. So either way, you'll get the same solution. Graphing in standard form, just plug in a 0 for x and y, or you can convert it if that's what you want to do. But either way, I have a dot, 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 dot line, and I just need to check. I'm either going to be shading this side of the line or this side of the line. So let's figure out what I want to do. Let's check that magic point 0, 0. So I've got 0 plus 2 times 0 is greater than -6. So I've got 0 plus 0 is greater than -6. So 0 is greater than -6. That is true. So what I'm going to do is I'm going to shade this way. Now so far the two examples I've done, the one with a greater than sign, I shaded above, and in the previous example, the one with a less than sign, I shaded below. That will not always be the case. Sometimes, and this especially happens in standard form, sometimes it happens in standard form equations. It'll be a greater than sign, and you'll actually be shading below the line. So just watch out for that. Okay. Oh, that's nice. Getting rid of all these dots is frustrating. Get out of there. Okay. So now that we're working with systems of inequalities, I'm going to have two equations. I'm going to do them one at a time. And the hardest part for this is that I'm sloppy, and maybe you are too. The other thing that's hard is I didn't make my thing go down far enough. Let's see if that's an easy fix. No, it's not an easy fix. Okay. So you're going to have to trust me that there's a dot. This is -7. I'm going to be graphing this line. This starts at -8, and it's going to go up 2 over 1 to -6 and up 2 over 1 like this, right? So my line, oh, dang it. Get back here. So my line is going to start, is going to go like this. Okay? It's going to cross there at 4. And this is y is greater than or equal to 2x minus 8. And it's a solid line that goes through there. I need to figure out which side I shade on. So I'm going to check that point 0, 0. So 0 greater than 2 times 0 minus 8. So 0 greater than or equal to negative 8. Yeah, it is. So I know that this line, I'm going to shade this direction. Okay. I'm not going to do all the shading right now because it's going to get pretty ugly looking. Instead, I'm going to go on to the next line, and I'm going to graph that first. So I get y is greater than negative 3/2 x minus 1. So that starts at negative 1. So I'm just going to leave one of those to remind me. Starts at negative 1, and my slope is down 3, 1, 2, 3 over 2. So it's going to go like this. And now remember, that's a dotted line that's going to go through. So they do cross right there. It's a dotted line because it's just a greater than sign. Now I need to figure out which direction that shades. So I'm going to check that same point 0, 0. So I got 0 is greater than negative 3/2 times 0 minus 1. So 0 is greater than negative 1. That is a true statement. So once again, I'm going to shade towards that truth. So if I shade that entire side, and this line shades this entire line, you can see that this center section, every single point in there makes both of them true, right? And so that entire field is where my answers are. So every single point that's right, that's in this zone, right? Like that point, that's like 2, 2, 6 or something like that. That's actually going to make both points true, right? So when you're solving system inequalities, that's what you're looking for. Okay, so let's transition back here now that we're done with that graphing. Get out of here, get out of here, get out of here, get out of here. Later. So I want to compound inequality. So I went to Costco and grabbed 400 frozen chicken wings. Sounds about right. Every day after work, I sit down and eat 12 wings on my desk. When will I have between 28 and 88 wings? So the way to make this happen is a compound inequality. I want to have between 28 and 88. So the amount of wings I have, I want it to be, if you just look at this half, right? I want it to be bigger than 28, but I also want it to be smaller than 88, right? So you can look at each piece individually, the wings that I have. So what I need to do is I can write it all in one. This is called a compound inequality. So this is the small number, and I want my wings bigger than that, which is less than that. So the way that we write this is 28 is less than, I start off with 400 wings and I subtract 12 every D for days. And I want to know when I have less than 88. So the way to solve this compound inequality is I have 28. I'm going to subtract 400. Now, remember, this is kind of like solving an equation with two equal signs. I need to subtract everything by 400. So 28 minus 400 is negative 372, which is less than, now negative 12D, less than, so 88 divided by negative 400 minus, big dummy, negative 312. So now my next step is divide by 12, divide by 12, divide by 12. And by 12, I mean negative 12, right? So same thing. I hear myself saying divide by negative 12. Remember, anytime you divide by negative or multiply by negative, we've got to flip the sign. So this becomes a greater than sign and a greater than sign. And this cancels out, so I just have D. So divide 312, and this becomes 26. And 372 divided by 12, this becomes 31. So I'll have between those 88 wings and 28 wings between day 31 and day 26. So what I want to do then is I want to put that on a number line. So the way to do that is like this. 26, 27, 28, 29, 30, 31. I put an open circle on both of those because those two values, I wouldn't be between 26 and 80, 28 and 88 wings during those days. I would be exactly at them. So they in themselves aren't solutions. So I put open circles on both of those, and what works? Every day in between. So I shade in between like that. And that's how many, those are the days that I have between that many wings. Okay. So last problem, this is number 13. Get out of there. 13, I say, okay, Brett and Kelly are saving a trip to ski in Utah. So I have Kelly and I have Brett. When does Brett have as much or more than Kelly? So when I'm looking for when Brett has greater than or equal to the amount of Kelly. So now I just need to write their equations. Kelly has $450 and is saving $7 a day. So $450 and he's saving $7 every day. Whereas Brett, he's only got $60, but he's saving $20 every day. So it's only a matter of time before he's going to catch up. So just like I'm solving equations, I got D's on each side, so I need to simplify that. So I'm going to subtract 60 from both sides, and I get 390 is less than or equal to 13D. Divide both sides by 13. So I get D is greater than 30. So from day 30 on. If I was writing a number line, I'd put 30 right there, 29, etc. It'd be a closed circle at 30, and days are bigger than 30, so I'm looking for every day 30 and up. Basically, like that. So that's what you need to know about inequalities.